All right, so today is automating solver. So we have a portfolio optimizer start.xlsm to download. So let's go ahead and get that downloaded and get it open. This is what we're going to work in today. So this is actually a model that's a lot more advanced than we're going to cover. I mean, there's a lot here, and the reason is that this used to be like the running example that I would use in this course to kind of show lots of different things. So like getting data from a website using user forms, so we would go through the process of building this form and so forth. So there's a lot here that we're not going to cover. It seems like you're going to need to, if you actually want to run this, it's probably wired to use this key right now, but if you all were to run this code that fetches historical stock data, would run out pretty quickly because we only get 500 requests a day. But the idea is that you would go to Alpha Advantage, sign up for your free API key, put your own API key there, and then you can, this workbook would actually work, pull the data in and so forth. Let me just kind of take you through what it's going to do. So one request to that data is going to bring back historical, historical data for the window that you specify. Right, so if we come back to this, we've got a start window and an end window. So yeah, so I guess the data that we're working with is going to be historic data from 2012 to 2019. So you'll recognize that this then has, don't go investing based on what we see here today, right? Because this has nothing to do with everything that's happened in the past 2 or 3 years. So, but that's the data that we have. So the idea is we're pulling in this historic data, and then we're going to end up with percentage changes. So this is month over month percentage changes. We're kind of getting a feeling for two things. Both how does this stock perform over a relatively long period of time, 2012 to 2019, and what's its volatility? So it's not just where was it then, where is it now, but how does it move month to month as we go along? And so we're downloading kind of one stock at a time for the stocks that are listed over here in our tickers column. I'm going to here. So it's bringing in this historical data. And then the main thing it's calculating is we want to see this percentage change. We then are going to copy that percentage change onto this consolidate sheet for each of those tickers. So these are monthly percentage changes that we have for each of these. What do we have? 10 tickers here, I suppose, up through J, yeah, 10. And so that's the base data that we're going to use to do what this worksheet is really built to do. And that is to say, given this set of stocks, so I've got this set of stocks, I can kind of look historically and find out what has the return been, what's like the average monthly return been for any one of these stocks. And I can say, listen, from whatever the highest return is, I can say, well, I'm just going to kind of look in the past and say, that's going to be my expected future return, what the past return has been. And I'll say, I can expect to get anywhere from what the highest return is if I was to allocate this bundle of stocks all into my best performing stock, or all the way down to allocate it into my worst performing stock. I can expect the range, I can expect a return in that range. Again, looking at historic data as a predictor for the future, which has its own set of problems. There's no way that I can allocate this stock to get this bundle to expect a higher return than my best performing stock, or to expect a lower return than my worst performing stock. In this bundle. So we're looking to say we're going to be somewhere in that range. And what we want to do is we want to pick somewhere in that range that we want to be, and then we want to minimize the risk, overall risk of this portfolio. What we want to do is we want to like minimize the volatility that we see in the data. So when one stock goes up, if another one goes down, if they're kind of working against each other, then those are two that I'd like to have in there to be able to reduce the variation that I see in the overall portfolio. So that's the idea. So how do we allocate? How do we say we want 10% of American Express and 5% of Apple and 12% of Ford and 20% of IBM and so forth? And the truth is, I do not understand all of the finance that underlies this model, but we've got then a summary here which gives us our, this is a correlation matrix here between each of these stocks. Here we've just got the means and standard deviations. It's just literally just the mean of that vector of numbers that we saw over here on our consolidated sheet. So American Express, that column is called AXP. presumably I could come over here and find the name AXP and it would select that vector of numbers. So all of that is like building this all happens as part of the VBA that brings the data in. So it names the ranges according to the stocks, which allows us to make the model, the rest of this model work a little bit more easily. Builds the summary sheet and so forth. Now we get to the model sheet. So here is where we're actually doing the optimization. And so let's start off just by seeing a show of hands here in class. Just kind of show me on a scale of 0 to 5 how comfortable you are with Solver already. 5, 3, 5, 5, 5. So a couple are down in the 2s and 3s, but most of us are up there. So the whole idea behind Solver is we say, listen, this is not just a formula that we can write to tell us the answer. What we have to do is we have to say, well, guess at one of these parameters and say, what does it look like if we plug in a 12 here? And then, well, what does it look like if we plug in a 13? Did that take us closer to the goal that we're trying to achieve or further away from the goal that we're trying to achieve? And that's what Solver does. So Solver says, give me some set of cells that I can play with, and I'm going to plug in values and try to achieve the goal that you've told me to achieve. I'm come as close as I can, subject to some specific constraints. So that's the whole idea. So Solver is, it's one of the add-ins that comes pre-installed with Microsoft Excel. This whole Solver logic was not written by Microsoft. It's written by a company called Frontline Systems, and Microsoft licenses the technology from them. I don't know that they pay a dime for it, but they certainly get a lot of exposure to, I really mean, I don't know what the agreement is between Frontline and Microsoft. What we're gonna find out is that if we record ourselves using the Solver, that it's gonna record VBA as well. So the good folks at Frontline Systems kind of wrote their own part of a macro recorder to be able to say, yeah, when someone records us, working with our tool, we'll get some VBA code. So clearly from time to time, you've looked at what the macro recorder has recorded and you said, wow, that's really weird. Why do they do it that way? Well, I agree. I feel the same way often when I see what the macro recorder recorded. But things are going to get even weirder today. At least what we've seen so far has all been done by Microsoft. Now we've got another company kind of with their own take on things coming in. So, but let's do this. Let's first start off before we record anything or before we do anything with VBA. Let's just configure the solver to run this model. So the idea here is that this set of weights is what we're going to ask solver to come up with. So this defaults to uniform distribution in this portfolio. So I've got 10 tickers. And so I'm just saying, listen, put 1/10 of your, whatever money you're going to invest here, 1/10 goes to American Express, 1/10 goes to Apple, 1/10 goes to Ford, and so forth. Now, what we're going to say is we're going to say, listen, solver, we want you to come up with better numbers than this. And what we're going to try to do is we've got a couple of constraints. The first constraint is that this is going to be our expected return here. So this is just the sum product of the weights and the means. And so this is going to be our expected return for this portfolio. We want that to be greater than some required return that I've specified here. So let's just kind of take a look. What is our best performing stock here? Who is it? Yeah, so you can tell this is pre-COVID if an airline is our best performing stock. So Southwest are our best, and who's our worst? So seeing a couple of zeros. Oh, IBM has 3 zeros. GE's even negative. Okay. So this looks like my range. Oh, it probably says it right here. Yeah, here's the minimum and maximum return expected here. And so I'm going to pick somewhere between these two. And right now it looks like I've got the maximum in there, so that's no good. So why don't we come here and just say I'm looking for a 1% monthly return, right? These are monthly numbers that we're talking about. And so this is, 1% monthly return is a pretty good return. So that's what I'm going to try to achieve. But what I want to do is I want to minimize my overall portfolio variance. So the higher my portfolio variance is, the more volatility there is in my basket. And so I'd like that to be as low as possible. So the model is play with these numbers such that we get at least, we're okay to have a higher expected return than this, but we don't want anything lower than that. And at the same time, we're going to try to find the lowest portfolio variance possible. I'm going to copy this one right here and just kind of paste it over here as values. So I can see this is what I had at an equal distribution in this portfolio. So, and I'm pretty close. I'm almost just a little bit above what my required return is. So I really expect Solver to be able to do a better job than just equal distribution on this once we get there. There's one more constraint here, and that is whatever numbers you plug in here, Solver, the sum has to come up to 1. And so a couple of constraints. Some of our weights has to be equal 1. Our expected return has to be at least 1%. Those are the 2 constraints. And what we're really asking Solver to do is change these numbers to push our portfolio variance down as low as possible, subject to those constraints. Got it? Tell me how comfortable you are with the problem we're trying to solve, 0 to 5. 5s and 5s and 5s and 5s and 5s. Excellent. All right, so let's just go ahead and do that. We're gonna have Solver do that, and then we're gonna record ourselves having Solver do that, and then we'll integrate that code into the rest of this solution that we have here. So I'm going to come to Solver, which I think is on the Data tab, and way over here is Solver. Now, if you don't have Solver showing, I can show you how to install it pretty quickly. It's here, you just have to enable it. Is there anyone saying, "Ooh, I'm looking at the Data tab and I'm not seeing Solver"? Excellent. Okay, so I'm going to open up Solver, and I'm going to start off by setting what my objective is. What is it? What cell am I trying to either maximize or minimize or try to get to a specific value? And that's going to be my portfolio variance. So it looks like either that was already in or I had that selected. But anyway, D12 is the right one. So D12 is the portfolio variance, and I want to minimize it. I'm trying to reduce the volatility in this basket. So next is, what am I allowed to change? And I'm going to be changing the weights subject to these constraints. I'm going to add a constraint. First constraint is that my expected return has to be greater than or equal to my required return. And I'll just add that constraint because I've got one more to go. And that is that my sum of weights must equal 1. And I'll say, okay, so I should have put those 2 constraints into the model. My unconstrained variables are non-negative, so we're not going to try to put a negative number in here. And I couldn't tell you the first thing about what these different solving engines mean. I'm going to go with the default on this. Now, when I click solve, then Excel is going to probably make thousands and thousands, maybe even tens of thousands of variations in these cells, trying to figure out what's going to be the best it can do here. And so you may actually see those numbers flash around just a bit, but it won't take long at all. I don't know. Didn't see them flash at all, so it just goes right to the solution. I'm going to keep the solution. It says Solver found a solution. That's great. Keep the solution. We'll say okay. So it gave me this distribution. It says, look, don't put anything into Southwest Airlines. We're able to get our expected return is even a little bit higher than our required return. And how does the portfolio variance compare here? So we were at 0.0013, and now we're at 0.0011. So it's able to reduce that portfolio variance a little bit or a lot. I don't know. Is that a little bit reduction or a lot reduction in the world of finance? I just don't know. But it's a better place to be than I was before. Whew. Okay, so that's the idea. Now, if my model is always the same size, in other words, if I'm always talking about baskets that have 10 stocks in them, there's not much I really need to do here in terms of automating Solver, because that model that we just built is now a part of this worksheet. That model is actually literally built into this worksheet. You can't see it, but it's a part of this worksheet. I copy this worksheet somewhere else, it would take the model with it. But where it becomes helpful to be able to automate this process is if the size of the model changes. So if I'm saying, no, I've got only 6 stocks that I want to optimize. No, I've got 20 stocks that I want to optimize. Now, that's stuff that normally you would have to go do by hand, change the constraints by hand. And so we want to, record ourselves doing this so that we can make these, make this part optimized or automated. All right, so I'm going to do this. There's another kind of gotcha here is that with much of what we do in VBA, we'll say, listen, we don't really care which sheet is active. Don't be activating sheets and moving cells around. That takes a long time to update the screen with all these changes. But Solver, when Solver runs, it's going to run the model that's on the active sheet. We've got to make sure that that sheet is active. So before I start recording, I'm just going to go ahead and select a different sheet. I'm going to come over here to my summary sheet, I guess, so that I record myself saying select the model sheet, because that's part of what I want this to do. And I'm ready to start recording. We're going to go through that whole process again. In fact, I think before I start recording, let me just see if I can bring up my VBA window. I'll have that side by side. And yeah, let's see. So right now I've got, what do I have for modules? I have just one module. I think when I start recording, it's going to make a new module, and I'm kind of hoping to see it kind of put this code in as we're going. So I'm going to go ahead and start recording. Hopefully we'll see it go. So developer, record macro. Macro 1 is a great name. We're going to integrate this code into the existing code base, so it doesn't matter what we call it here. And it's made module 2. So I'm going to open up module 2 so we can kind of see it as it goes. Okay, so I'm selecting the model sheet and it's recorded. Select that sheet. Excellent. Okay, so now I'm going to go ahead and open up Solver. So back on my data tab, going to Solver. Now, the whole idea here is that this is going to get integrated. So when the user says, this is my basket of stocks that I'm doing, the code's going to run, it's going to do the whole solver and everything. I don't know what my user may have done to the solver sheet. I mean, if they've come through the MBA program here at BYU, they're going to be comfortable looking at that solver sheet, and they might have changed something, and I just don't want to rely on what's there. So step 1 is going to be, let's reset the solver. And so we've got reset all button. I'm going to go ahead and choose that. Reset it all. Yeah, okay. And so we can see then it's brought in this statement, solver reset. That's the statement now that's going to reset my solver. All right, I'm going to go through that same process. So my objective cell is going to be my portfolio variance. I'm going to minimize that by changing these weights subject to those same constraints. So my expected return has to be greater than or equal to, or my, greater than or equal to my required return. That looks good. I'll add that one. My sum of weights has to be exactly equal to 1. And we'll say, okay. We've added in, oh, I missed this other one. We can see that that first one, greater than or equal to, put a relation of 3. This one, equal to, puts a relation of 2. And so they're using some kind of numeric scheme here to keep track of, what kind of solving that we're doing. Min-max value is 2, so that's going to be minimized. Set cell, so we can kind of see this coming in. That looks pretty good. Let's see. Tell me that again. Oh, I went too far. I totally believe you, even though I'm not quite understanding. You're saying this should be F10? Formula text, F10. Yes, you're exactly right. So we'll change that. Actually, we can change it. Let's change that in the code when we get to when we're done recording. Okay, so I'm going to go ahead then and solve. So there's solver solve, which is the statement that says, go ahead and run solver. And then I'm going to accept this, keep the solution, okay. And I'll stop recording. Okay, so here is the code that got recorded. Let's go ahead and make that change where I had the typo, which is instead of F12, this is going to be F10. And that plus should be an equal sign. I think it would work as a plus, but I think it makes more sense as an equal sign. Equal to F10. So we're saying this one has to be greater than or equal to this one. Now, a couple of things are interesting. Solver reset looks pretty good. As soon as we set what we're maximizing, in this case minimizing, cell D12, we get this statement here, solver okay. So far, so good. We're using this engine. We're changing this set of cells. And then we add the two constraints. These constraints look pretty good too. Little problem with one of them that we're going to have to modify here, but we'll see that here in just a minute. And then we get another solver okay. What's the difference in this solver okay from the other one? Can you see what's different about these two lines? Nothing. They're exactly the same. And there's no really good reason for them to both be here. So we'll delete this one. Same with this one. We got another solver okay. I'm not sure why these come in, why they get recorded, but it's not giving anything different to us. So then we get solver solve. Let me just go ahead and just kind of to check this code. I'm going to come back here and just put 10% on each of these. And we're going to run it then and see what we get. So we'll be selecting the sheet, resetting it, configuring the solver, and telling it to solve. Solver found a solution. That's the first thing that's a little bit annoying. I don't think when I solve this, I want this window to pop up. So we're going to put a parameter here on solver solve. So you can see that we have this. It actually has an optional parameter here that doesn't get recorded, and that is user finish. It's a Boolean property. So what do you think? I'm going to put either true or false here. Is user finish going to be true so that it finishes without intervention, or is it user finish going to be false so that it finishes without intervention? User finish true. I think that seems backwards to me. I think it should be user finish false. Don't let the user finish it, just finish it on itself. But I think true is actually right. So let me go ahead and just put this back. Guess I can paste it this way. And so now I should be able to run that again. And now it happens without intervention. So we're going to put true here for solve, and that's going to just say, yeah, accept what it finds. But what is the problem here? We gave it a constraint that said the sum of weights needs to be 1. And it doesn't seem to be honoring that constraint. In fact, it's not honoring that constraint. This is a weird thing. So this is a point where if you don't catch this right, it's yeah, your model's going to be wrong. And it's right here. The little hint that we have here, it took me hours to figure this out the very first time I came across it. But this little thing here says formula text. So here, when we're putting in this, we're adding this constraint, we're saying this cell, G7, has to be 2, exactly equal to. And then this is asking for formula text. And have we given it a formula? No, we've given it a 1. It's no formula. That's just a literal. I have no idea why this in this code here needs to be a formula. So I'm going to change that to equals 1. And now all of a sudden it's a formula, and I think we're going to be in good shape. So now it respects that particular one. I have no good excuse for that. But it really does have to be a formula. So even though it works as a literal when you put it into solver, you've got to have it as a formula in your code. Questions? Okay. Oof. So now let's go ahead and integrate this into our code. So let's take a look at the existing code that we have here in module 1. So let me open up my immediate window. Oh, it's already open. Let me open up my Project Explorer and my properties as well. Okay, so I'm coming back to module 1. And we've got some code here. This is going to show the form to actually let someone enter the tickers on that form. This is the one that's going to get the data. So it clears the old sheets. It builds the new sheets based on the tickers that are selected. It calls get data, which will go and populate that data. But now this, build model is the one that does everything. So we're going to call something called summarize. We're going to config solver, run solver, and then find frontier. So summarize the data is already happening. So if we were to find summarize, we'd see that it's kind of fully, code is kind of fully written here. So what we want to do is after the data is summarized, we want to configure the solver. So let's come here to configure solver. So I'm just going to copy the code that we recorded, and I'm going to drop it all in here, even though it's more than we want. That'll get everything over here mostly in the right place, but just a little modification to do. So I'll copy this whole block of code, and I'm going to bring that into configure solver. This looks pretty good. We're going to select a sheet, reset, set it up. Now, I don't really want to solve it here because this is just the configuration. So in other words, this code needs to run just after I've changed the size of my model, because it's going to say, this is the code that's going to say, hey, let's go ahead and get this configured the way that, for this model now. Now, in addition to finding that basket that I've specified, this code will also find the efficient frontier. So it'll say, well, what if you only need a little bit of return? What's the best way? What if you need a little bit more, a little bit more, a little bit more? And it's going to plot a line for us that we can say, we're glad to be anywhere on that efficiency frontier. We can't be to the left of the frontier, and we don't want to be to the right, because if we're to the right, then we've got more volatility than we need for the expected return that we're after. So it's going to run this model multiple times, but we only need to configure it once we've gotten the data. So that's why we got config solver separated from run solver. And that's where we want to say the solver solve statement. So now, in fact, I think this button is probably already wired up to run that solver solve. So let me assign macro. Yeah, so this is already, so this is running run solver. Is that the one? Yeah, so that button is already wired to do this. So now that I've put solver solve in here, I should be able to come in here and say 0.01. And the optimize button should do that. So it's just saying run the solver model that we have. So just that alone is nice, because someone could come in here and say, what if I'm after 0.011? It's going to optimize a little bit differently. We're bringing a little southwest to be able to get that. So they don't have to go through solver and run it. That's enough to do it. Oh. Now, I do want to point one thing out here, is that the rest of this code, so we've got by changing right here. So this is something that we're going to have to configure, right? Because this is saying from B4 to K4. And that's going to change depending on how many stock tickers I have. But you're going to notice here that what we have is when I select that range, you'll notice I've named that range. And so we've got code that's already naming that range. So as we, when we run this again, if we get more stock tickers, the weights range is going to be, it's already going to be adjusted for that. So one approach would be for us to do some kind of end Excel to write or something to figure out what this formula is. But because we have a named range, we can just plug that in here, weights. And that's the only thing that's really changing, because our sum of weights will always be in the same place. It's just how many we're going to be modifying. So let me go ahead and configure the solver and go ahead and run it again. It still likes that change that we made with the weights. But I'm curious to know, did it actually change the way the solver looks? Come to data, solver. Yeah, so it actually says weights in there for the cells that we're changing. All right. Well, we've got this find frontier. What find frontier does, let's take a quick look at the code, is it's saying, listen, how many observations do you want to make? In other words, how many different points do you want to solve to be able to create this curve? And I've just set that arbitrarily at 10. And so actually it'll be 11 because we're going to go from 0 to whatever that increment is. And all we're doing is we are going to change what's in the required return cell to be some portion of our distance between our maximum return and our minimum return based on our increment. And so the first time we run it, it's going to be just the first step into that increment. The next time it'll take 10% more of that difference between the minimum and the maximum and so forth. What it will do then is it'll run the model. It will then copy the weights over to our frontier. So it'll copy those weights into here, and it'll give us our standard deviation and required return, which is what we're going to use to build this efficiency frontier. And we can see it, we can kind of go through and see it copying those things over. But I should be able to run this find frontier now. I'm going to go ahead and select my model in case it's expecting that model to be active. And I'll run that find frontier. It has then gone through and run that model 11 times, changing the required return each time, and then optimizing. And so it gives us this curve here, which says based on the required return that I'm after, I'm going to accept more or less risk over here. So there's no way to expect to be to the left of this line. I just can't get there. And if I'm to the right of the line, then I'm taking on more risk for a given amount of required return that I'm after. So that's the line that's plotted by this data. And so whichever required return I'm after, that's the allocation that I would use to get that based on this historical data. So the finance part here is interesting, but what we're after here is the automation of solver. Questions? I'm trying to think of what else I must have done last time I taught this to make it take a half hour longer. We certainly could look at the code that goes and pulls the data down from Alpha Vantage. That's not really what we're after today. So, questions?
Yeah, so like if we wanted to add like 2 extra stocks to our analysis, could we make like a code that automates that?
So we're already here. This code already does that. So if we were to come in here and either just add 2 more tickers down here at the bottom and then get the data, it would pull in all of that data. So all this, what our consolidate data has, the 10, it would bring those in as well. So for you to run that, you'll want to get your own API key at Alpha Vantage. and then that would run. Other questions? I'm probably using a different way to get this data. I mean, the way that we saw to get data were two. One was using the data, the web query wizard, and then one was automating Chrome. There's another way, and it's probably worth just at least a little tour of this code so you can be exposed to this approach. So that's going to be something on probably get data. You take a look. Oh, I've got something called get historical data. So get historical data is taking location. I'm not sure if that's where the data is from or where the data is going. It must be where we're going to put the data, because we're passing in a ticker, a start date, and an end date. Looks like I've got to get the date as like names of months in the URL. And so there's a little work with an array here to convert numeric representation of a month into a named representation of a month. Oh, and you can kind of see the different places that I've gone over the years. Initially, I got this data from finance.yahoo.com, and then they must have changed something that wouldn't let me get the data anymore. So I went to Chart, and that worked for a while. Investopedia worked for a while, and currently we're pulling it from Alpha Vantage. So this is the URL that we're building, and do we have month over here? API key value. So it's expecting a time series adjusted. I mean, this is the URL that we're after. So query function time series adjusted. The symbol is the ticker that's passed in. The API key is what is kind of saying, hey, I am authorized to make this request. The free one that you get has some limitations, like it can only pull 500 a day. And I think you've got to wait like 4 or 5 seconds in between requests, so you can't hit it hard. And then API key is that. Data type, I want it back as a CSV file. Somewhere I've got to be telling it what the range is, though. I don't quite see where I'm telling it what the range is, but here's the object. So this XML HTTP object is an object that we can build an instance of, kind of like building an instance of the objects that we use for sending email, or the objects that we use for interacting with databases. And in other words, it's something that's not native to Excel, but it's objects with methods and properties that we can manipulate. And so we're setting a variable called HTTP equal to this object, and then we are calling the open method of this object, telling it we're using HTTP protocol. There are several different methods that we can use to send that request. Get is the simplest one. So we're saying using the get method, send the URL that we formulated up here, and false as if this is a background request. In other words, by putting false here, my code is going to wait until the data comes back. Actually, once I say send, opening it just gets it ready. Once I say send, it's when it actually sends the request off to the server. And then this is going to be going through the CSV file that comes back and putting it out onto the sheet. So this is, this object works great as long as you don't have to log in. And in this case, there's no logging in, and that's common with APIs, right? There's not a separate form you have to go through because it's meant for a computer to make the request. But instead, the authorization happens by supplying the API key. And that happens typically either by setting the API key as part of the URL, which is what we're doing here, or by putting the API key into a particular header for the request. And there's just another method that you would use after you call open. It's called set header that would say there's some information I want to put in the header. It's information I'm sending to the server, but it's not part of the URL. And so this is like the other main way to go and get data. It's faster than using the web query wizard, but it has similar constraints in that you can't, you're not going to be sending, like maintaining a session. So you can log in and then have other requests kind of be authenticated by that login process. Unlike the web query wizard, however, you get back the HTML. So you've got the whole page to work with. Whereas the web query wizard only gives you stuff that's visible on the page. So that's the code that's making these requests here. And if you're kind of interested in going that into more detail, give this a try. If you have other questions, reach out to me. I'll be glad to talk you through it or help you adjust the code to whatever site you're working with. Okay, other questions? Question is, when am I going to publish that final exam study guide? And I really hope I have it published already. So I think if we come to the schedule, yeah, it's down here on the last day of class. So final exam study guide is there. I tried to take the exam to the testing center today, and it turns out I had never asked MBA 614 to have a final exam. And I thought, oh no, am I going to have to cancel the final exam? That would be no fun for anybody, I'm sure. But fortunately, the testing center was able to accommodate me. They said, no problem, we can still get that set up for the MBA portion of the class. So exam will continue as scheduled. Darn it. Don't tease us, Professor Allen, don't tease us. Oh, hey, and one other thing is that we have a extra credit. There's an extra credit assignment that is worth a homework assignment, and it's just for filling out the course evaluation for this course. So make sure when you go fill out that course evaluation at studentratings.byu.edu that you check the box that says, let my professor know that I've filled out the evaluation, so I can give you credit for that. All right, if there are no other questions, we'll call it good for today. Thanks for coming, class dismissed.